So next part of the presentation, we'll talk about groove types. This is often overlooked. It's taken for granted that with a groover, you just plunge in and you retract. But there are far better ways to produce grooves. There's some strategies here that will prevent you from creating rings on the part or putting damage on your insert unnecessarily. So the first simple type of groove is plunge in, plunge out. So that means you don't have a chamfer or radii at the corner here. You're just plunging in, plunging out. Basically uniform stress on the main cutting edge. You can use geometry with chip control and forming to help you do that in the best way possible. Here's a common way that grooves are produced, which really shouldn't be done. And the reason that you shouldn't do it this way is you have uneven loading, you have geometry, you have to use a geometry with chip control and forming. Your secondary cutting edge is required, so you have to use one that has some sort of geometry on the side here, ability to cut. And then the biggest is your risk of ring formation. So we've all seen the rings that can be produced on a part. You have to stop the machine to remove them so they don't damage other operations. And it's not a good process. So the no process is chamfering, plunging, retracting, and chamfering on the way out. So one, doing the chamfer, then plunging to the depth, then retracting to below where this chamfer is, and then chamfering your way out of the groove. The reason this can cause a ring is right here at this step 4, because what can happen is the material, there's not much material being removed here, so that can depart and then get slid onto your component. So you can be unlucky with that by doing it this way. So don't do it this way. The better way to produce a groove with chamfers is to follow this process. So first, plunge to just below the chamfer that you need to produce, then retract. Then in step 3 and 4, produce your chamfer, so bottom out just below here. And then 5 and 6, you plunge to the depth of the groove, and then you retract. So this is no risk of ring formation. It's very uniform loading of the insert. A secondary cutting edge is not required because you're using the front of the tool, the business end of the groover here, and not the side. And it's just a better way to produce that. You can also buy an insert with the chamfer built in. So that's a very simplistic way to minimize programming. No risk of ring formation because you're just plunging in, plunging out, and you're still getting those chamfers. The other way to produce a groove, and this is a groove that is wider than your cutting tool. So the groove width is wider than your groover, is to plunge the center, then retract, plunge 2, and plunge 3. Now, if you have a deeper part, a bigger part, it's better to go with the internal plunge first, or the plunge closest to the spindle or the fixing, the clamping, and then do the outside because that leaves you more room to have chip evacuation. In the case that you have very small parts, it's been brought up before, it's a good idea to pay attention to that and do the outside first and work your way towards the fixing, because you're removing some stability of the part. So keep that in mind. So this type of process also involves partial cutting. So you're on the first plunge, you're using the full width of the insert, and then 2 and 3, you have a partial plunge. So really better to plan that out to be between 70% of the width. You don't want to go like 50-50. So plan the process out with the right width so that you can have one plunge in the center, and then you're still going to have 70% of the width here. You want to make sure you use a partial cutting geometry. So some of our geometries are not good at partial cutting. The L, the A, and the HR are partial cutting geometries. The 5 and the F are not. So we saw from our training last week that there are some that are not great at partial cutting. So you want to avoid those and stick with the ones approved for that. The reason partial cutting can be damaging to your insert if you don't use the right type of insert is in a partial cut and you have the right insert, the chip is funneled towards the center of the tool. And so that minimizes the risk of the chip hitting the opposite wall and getting tangled, or the chip getting hung behind the insert and causing damage to your insert. So the A geometry here you can see is a good option for partial cutting, where the 5 is not, because the chip, once it passes the center point here, it's funneled, but then it can go what direction it wants. And so it's not a good choice for that partial cutting. Doesn't mean it won't do it, but we just recommend the A definitely over the 5 for partial cutting. Another option to do a wider groove is to follow this process, which is to plunge left, 1, 2, and then plunge the upstand that's left, the 3. The advantage there is that you can increase your feed 100% for that center. So for instance, by doing that, you're going to improve the cycle time of this part significantly. Also use 70% of the width should be left in the center. You don't want to leave something that's too narrow that can, instead of cutting, it gets bent and causes a collision. So always keep that in mind. You want something of decent width there, 70% of the width, so that you don't have a part of the material bent and not cutting. A cautionary way that you can do a really wide groove is not recommended, but you can plunge and just keep taking steps. So plunge 1, 2, 3, 4, 5, 6, and 7. A better way to do that process that will save you time is to plunge and then skip plunge 2, plunge 3, plunge 4, and then take all of your upstands and plunge those at increase the feed 100%. So you're going to save quite a bit of time because you can feed these at a faster feed rate. So skip and then skip a space, and then plunge, and then plunge, and then plunge, and then come back and clean those upstands off. Again, make sure they're wide enough to take care of that, to cut rather than to collapse. Another good way, if you have a very wide, a very deep groove, is to utilize plunge and turn. So you can plunge and then turn to the right, plunge, turn to the left, plunge, turn to the right, plunge, turn to the left, plunge, and turn to the right. The key in this, doing it this way, is to leave 5 times the feed rate at each level. So you're going to leave 5 times the feed rate, whatever that is. So if it's 80, if it's 8 thousandths per rev, you're going to leave 40 thousandths each step. And the reason to do that is because you're going to minimize the chance that you're going to pinch a chip behind the insert. You're going to leave plenty of clearance, and you're not going to have any collisions along the insert. So it just helps to um, to minimize pinching the chip in the pocket. And then on the last part of this, you're going to plunge and clean up your stair step in 1 or 2 plunges. So 5 times the feed rate. All right, surface finish. Different grooving methods result in different surface finish qualities. Additional finishing operations might be necessary. Often times, if there's a pretty stringent requirement on surface finish, you're going to want to rough with one tool and then finish with another, and that's going to give you the best finish, the best result. And to be honest, it's going to give you a longer time where your dimensional accuracy and your finish are maintained. So one thing to avoid in finishing is doing an overlapping pass in this way. So rather than plunge down the side and then turn, and then skip to the other side, plunge down and turn, that's going to create a little area and a potential for a ring. And you want to avoid that because you got to stop the machine, cut that ring off if you have other operations, and it's just a hassle. So try to avoid the process of sort of overlapping passes. The best way to finish a groove and also avoid the ring is to plunge and turn and just leave the least little bit at the end to do a plunge and clean up and match up with your other pass. This is the preferred method for doing a finishing on a groove. If you make use of the turning geometries that we have, the grooving geometries for finishing, like the NC, the ZG, our newest would be the FB geometry, then be careful of your overlap. Always just put an eyeball on the tool and make sure that you're overlapping the center because the bottom here is on these tools they're ground, but there's a relief in the center that reduces the pressure on that groover so that you don't get chatter and you get a better finish. So you want to make sure that you don't plunge down and leave material at the bottom.